Welcome to myiacademy.com. I'm Professor Mahfooz from Pakistan. In this video, VHB 16.4, we'll talk about the visual fields for the undergraduates and allied health workers. These are all the different types of ophthalmic investigations. Number one is the B scan, which is actually an ultrasound through a corneal opacity or a cataract or a vitreous hemorrhage. Number two is the OCT or optical coherence tomography, for which you use the light through the clear media and you can see the retina layer by layer. Number three is the fundus fluorescein angiography, which is for the leakage and blockage of the blood vessels. We are going to talk about the number four today, while the number five is the corneal topography, which is for the shape of the cornea, and number six is the A scan, which is to find out the length of the eye. So today we'll talk about the visual fields and for finding out the defects in the visual fields. Now, visual field is also called perimetry, so you may advise a perimetry, which is the same thing as the visual field. The source is the light. We use the normal light, and the purpose is to find out the extent of the visual fields. Like over here, this person can see only in the center, while the peripheral one is shown as the black, so this person cannot see to the sides. So that's how we find out the extent of the visual fields. And the uses of the visual fields are to detect the defects in the visual fields and to help the diagnosis of the glaucoma and the lesions causing the optic nerve, optic chiasma, optic tract and cerebral damage. So with the help of the visual fields, we can diagnose glaucoma and different pathologies of the optic tracts. And this is how you do the visual fields. You've got a dark room, and in this machine, which is called visual field analyzers, the light will keep shining. Look at this area. The light will shine. Every time the light shines, you will press the buzzer. And here is the buzzer in the hand. So that's how you plot the visual fields, and this is the computer screen. Every time you see, it marks it as a seen, and if you cannot see a spot, it marks it as an unseen, and that's how you differentiate between the seen area by the eye and unseen area by the eye. Let's see in the next slide. Now look at the different visual fields. In this visual field, the central area is seen while the peripheral area is not seen. In this one, the temporal half is not seen while the nasal half is seen. In the third photograph, the central part is seen while the paracentral part is not seen and the periphery is again seen. In this one, both the temporal half cannot be seen while both the nasal half can be seen, so the visual field is plotted as the nasal half of the fields are seen while the peripherals are not seen. Now look at the difference. What is the difference between the right hand side visual fields and the left hand side visual fields? The difference is, on the right hand side, the field defects follow the center line, across the line, across the line. So one side of the line you can see, and the other side of the line which passes through the center you cannot see. While in the left hand ones, it doesn't follow the center line, rather it is a circular type of field defects. So it is a circular field defect, and this one is a circular field defect as well. So the difference is, those ones which follow the center line passing through the center of the eye are because of the chiasma, optic tract or cerebral cortex lesion, while those which do not follow the center line and are circular in appearance are usually because of the glaucoma or the retinal lesion. So the difference between the two is, if you cross the center, this is because of the chiasma, tract or cortex, and when you don't cross the center and follow a circular pattern, that's more commonly because of the glaucoma retina. Thank you very much for being with me, and you can subscribe to the channel to see the upcoming videos. Thank you very much.